Introduction to Imaginary Numbers by me, Ashton Lian. Now, what is an imaginary number? An imaginary number is represented by the variable I, and I is a weird number in the math world. I is equal to the square root of -1. And why is this weird? There's a negative in the square root sign, and that's normally not supposed to be there. However, I is an imaginary number, and imaginary numbers are, as the name implies, imaginary. So they technically don't exist, yet they do. Now, there are certain situations where you can get an imaginary number, like, I don't know, like a square root of -7 or something like that, but in this lesson we won't be covering that. In this case, so we know I is equal to the square root of -1. Now, if we were to list some i's in different power forms, for example, I to 0, we know is equal to 1, since every number to the power of 0 is equal to 1. I to the first is that number times 1, so it's square root -1. I to the second is that number times the same number, so I times I, which would equal -1. I to the third is I squared, which is -1, times I. So it's negative square root -1. And I to the fourth is equal to I squared times I squared, which is just 1. Because -1 times -1 equals 1. And here's the fun part. I to the fifth is equal to 1, which is I to the fourth, times I, which gets you all the way back to square root of -1. Keep in mind this pattern, how there's there's 4, and then it's back to the beginning. So let's try an example. An example, let's say, is I to the 7th. What is I to the 7th? If we were to do the pattern, if we were to just list all of the powers, so I equals square root -1, I to the second equals -1, I to the third equals negative square root -1, I to the fourth equals 1. Back to the beginning, I to the fifth equals square root -1, I to the sixth equals -1, and I to the seventh equals negative square root -1. That's your answer. But look at the pattern. So we know that the pattern is in 4 terms, and it restarts after the 4th term. So it restarts at I to the 5th. So we can just technically, an easy way to remember this is you take the problem, so the problem was I to the 7th, and if it's over 4, you subtract it by 4, and don't use this notation, but that's just for this situation. So I to the third. And then what's I to the third? Easily remembered, negative square root of -1. Let's try another example. Let's try a big number. Let's try I to the 16th. So what is I to the 16th? Well, we can subtract it by 4 times, and it would be I to the 12th. Oh, we can still do it. So -4, I to the 8th. You can do it one more time. I to the 4th, and I to the 4th equals 1. Now, here's an interesting thing. If you do it one more time, it would just give you I to the 0, and I to the 0 still equals 1. That's pretty interesting. So for imaginary numbers, so in this case it just would equal square root -1, and so on in patterns. And we can remember this pattern by the powers all the way to terms of 4. So I to the first, I to the second, I to the third, I to the fourth. You don't really need to memorize I to the fourth. You can instead do I to the 0, but I recommend I to the fourth because I don't think you'll see I to the 0 too often. So -1, negative square root of -1, and I cross this out, but let's just say 1. So just remember this pattern and go by this pattern, and you just keep on going, and you can pretty much figure out the answer if you have a I number to a certain variable. And that's basically it. Imaginary numbers may seem pretty complicated at first, but it's basically just memorizing the patterns of it. Otherwise, it's a pretty easy concept to grasp. And so that's the end of that. And so that is the introduction to imaginary numbers. Taught by me, Ashton Lian. Thank you for your time, and I hope you grasped the concept.